Okay, guys, we're almost finished, and I can start showing you some videos and some video footage of us actually processing samples together. But a few more things that we want to talk about before we get to that point. So next up, for the headspace system, we have to have a heating block. And the heating block is what's going to heat our samples up. So on the inside of this block, there's going to be one of our headspace containers, and that headspace container, of course, still has the lid. On top of that lid, there is a little piece of rubber, and there is a needle that will puncture that piece of rubber, and it will suck out all of the air that's on top of our sample in the headspace container. Now, I say air, but it's more appropriately called the headspace. So it's going to suck out the headspace of the vial, and it's going to inject the headspace into the instrument. It is just simply a gas plug. That's all that this thing is. No liquid is going to get injected at all. No blood will get injected at all. Only the things that get released and go up into the upper chambers of the sample container will actually get pulled out and injected onto the instrument. So this is the heating block, and this heating block has two purposes. Number one, it will jiggle, 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 and number two, it will provide heat. And I know it provides heat because there's a warning, warning, warning sign on the heating block. All right, so there's a door up on top, and this door will slide back and it will go forward, and that kind of seals off the chamber a little bit, so that way these sample containers can heat accordingly, shake accordingly, not be disturbed, and that lid just keeps them all contained, of course. So sooner or later, that big tower that you saw in the previous video with that little magnet on it, that's going to go over the oven and lower a sample in. It's going to go over the oven and inject a needle through the cap and suck out the headspace. And then it's also going to go over and grab a container again and take it back to where it came from. This particular oven, I believe, can hold 6 or 8 different sample vials. We'll see that when we see these videos in action, but it can jiggle and it can heat more than one sample container at a time. That way it saves you time in the long run. It can make a plan, and it can go ahead and start heating one of the samples while another one is getting processed. It can do more than one thing. It can multitask. It's just like you. It has to multitask in order to do its job. All right, so here overall is now the picture of the GC FID system that has the headspace technology. So our headspace system is up here at the very top, and that is our AOC 6000. And then here you can see the oven on the right hand side for the headspace system. Here's the racks of containers that you can utilize. So liquid injection as well as headspace injection here. Here is the hydrogen generator to the left. Our GC system that sits directly below. We've got our sample inject that's going to be located here. We have our FID detector, that's the exit point of the machine that's there. A couple of gauges that's toward the back that we talked about why they are present. And then, of course, the gas tanks and the regulators that sit over on the left-hand side. And that will be our helium, and that will be our air. So as a whole, folks, that's the instrument that we are using today. All right. So next, I'm going to show you a video. We're going to go through some of the same kind of stuff. I think the more that you see it, the better off you're going to be. And it's just going to be in a video format now. And I'm just going to let myself, within myself, begin to talk. All right, guys, it's time to load samples up on the instrument and 2014 from Shimano. All right, guys, it's time to load samples up on the instrument, and this is our GC 2014 from Shimatsu. It is a headspace system. You can see the headspace system up here on top. The GC itself is here, and then to the left of that, that's where our hydrogen generator is. So to turn the machine on, which is the first thing that we're going to go through in this video, there was a power button here on the right hand side. So I'm going to flip that, and that cuts the power on to the GC system. It's going to start up. Then there's another power button over here on the right hand side. So I'm going to flip that, and that cuts the power on to the GC system. It's going to start up. Then there's another power button over here on the left hand side of the hydrogen generator. We like to make our own hydrogen as needed, so that way we do not have hydrogen tanks that are just in our lab space that can go boom. With that said, we do have a backup hydrogen tank just in case we do need it at some point in time. There's also another power switch, and the other power switch is up here to operate what we call the Game Boy, which in this image it's almost out of sight. The Game Boy is up here at the very top. It's a handheld device that controls the auto sampler and then the auto sampler itself. So that power switch is going to be back here to the back, and I'm going to flip that on as well. So 3 power switches that operate this instrument: the auto sampler and the Game Boy piece, the GC, which is right here, and then the hydrogen generator, which is here to the left. Now, with each one of these, I'm going to zoom in a little bit closer so that way you can see what each one of these things will be doing as we begin to analyze our samples and to process data off of this thing. One of the first things that I'm going to show you in the next video is the hydrogen generator that's here to the left. We need water in that generator, and there is an opening up here at the very top of that instrument that we will have access to a well or a container, and that is where we put deionized water in. So again, I'll zoom in a little bit closer. I'll kind of show you where we would do that. On the front of the hydrogen generator, you see a water level. My water level is like right here currently. Now that we know water is there, we don't really necessarily need to refill it, but that is something that we can do sooner or later. Up here at the very top, you're seeing the auto sampler that's getting ready to kind of do its job and move around. It's just kind of figuring out where the home is at, so it's somewhat trying to reset itself if it can, and it's just double checking everything to make sure that it is ready to go. So that is our auto sampler, very, very tall, much taller than I am, and this thing is just going to go through its motions, making sure that the startup is going to be a breeze and that it's ready to analyze our samples fully. We'll kind of look at the auto sampler when it actually starts running samples a little bit closer, but for now, this machine is now started up. All right, guys, so it's big, it's impressive, and it's also very expensive. So not the most expensive piece of equipment that's in our lab, but a fairly large chunk of change went into this auto sampler as well as the GC system. The reservoir that I was talking about for the hydrogen generator looks like this. And then these caps are going to be used to put your water in. So if you had to refill it, you just take the lid off. You would add water into that reservoir until you saw that that level gets to a point that you feel comfortable with. And then you just close that back. Again, that water should be distilled and deionized. So it needs to be a little bit cleaner than what we use, but our deionized water is pretty good. So I don't feel bad about putting deionized water in, but if we had like an ultra pure water filtration system in our laboratory, we would definitely be using that ultra pure water for the hydrogen generator and many other things at the same time. All right, so the next video is just going to focus on getting the instrument connected to the computer. How do we do that? Because we're going to be operating this through a software, and that's what this video is going to focus on. All right, guys, so to turn the GC on and connect it to the software on the computer screen, we're going to go to this icon. On our computer, it's over here to the left-hand side called Lab Solutions. Lab Solutions is the software that Shimadzu uses most of the time for all of their chromatography or instrumentation. They're just slight modifications of them depending on which instrument that you're using, which is why it's called Lab Solutions and not something that's specifically tailored to GC systems. This prompt prompt is going to pop up. This is a username and password that companies can use to control who has access to what. So we don't really have a user ID and a password to access our software. So admin is going to automatically pop up here in the username, and then under the password we just leave that blank and we hit OK. So this is going to be our working computer screen, and there's hardly anything on here that we can actually touch or click or select, except for a couple of things. Over here to the left-hand side of the screen, you're going to see some big buttons. This one says Instruments. This one says Post Run. This is Administration, and this is a manual. Most of the time we are going to be working under Instruments because we want to control the instrument with our software. Post Run is where I would go in order to look at reports after they are generated, after samples are ran. I'll click that button, go into that area, and that's where I'll start looking at data, those types of things. Administration is going to be for username, password management, who has access to what. And then the manual button is, of course, the manual of the instrument and the manual of the software. So we fall under the instrument button most of the time. It's going to be defaulted up here at the very top. And then right beside of that, it says GC 2014. There's only one instrument that is connected to this computer, and that's the way that we like to run the show in our laboratory spaces. So I'm going to take the mouse and I'm going to go up here to the very top, and I'm going to double click GC 2014. When I do that, it's going to send a message to the instrument, and it wants to make a connection at this point. So that pop-up box and that beep that you just heard says connecting to the instrument, so it's establishing a connection, so that way my software can now operate the piece of equipment that sits over to my left. A couple of things on the software screen that we'll talk about in the next video, but this is the way that we get our computer booted up and our instrument signal established, and then here is where we tell the machine kind of what we want to run, what temperature should we hold things at, how long should things run for, and we'll talk about that in the next video when you come back. All right, so a couple of things I want to mention on the software that maybe you had a harder time seeing in the video. The desktop icon, a closer view of that looks like this. It's called Lab Solutions. And as I mentioned, Lab Solutions is kind of Shimatsu's way now of building a software platform that looks very familiar amongst all of their different types of laboratory equipment that they have. So if you are trained on Lab Solutions, whether it's for a GC or an HPLC or whatever the case is, it looks very familiar to you. The buttons are going to be in the same type of area. And you're not getting weirded out because you got to learn where new software is and how to process things. The startup screen will say Lab Solutions, and then underneath that it says it's a GC version, so that way these screens and these tabs are going to be gas chromatography specific and not other types of equipment like infrared or HPLC, mass spec, and so forth. When that screen disappears, here is our prompt box to put a username and password in. Again, we do not use them, but do not be surprised in real life if you're giving your own user ID and password to log in to the software and to do things that you have the responsibility for. Now, as you can imagine, entry-level people that are running instrumentation like this would have less of I guess valid reasons to go in and make settings and modification changes and so forth, so they just block you out of those types of things. But the higher up you are, the more administrative role that you will have full access to the software. We provide that access to everybody. It does not matter. Once that establishes a connection, it says connecting. That's when you heard the beep. And then up here in the top left-hand side of the computer screen, you'll see GC 2014. The reason that this is popping up that way is because there could be an instrument here, an instrument here, an instrument there, one here, one there, one there, and all of these could go to multiple instruments such as GCs that are in the laboratory setting. So that one instrument can actually reach out and operate more than one machine. So that one computer and that one software can do multitasking even more so. We do not like that type of setup. Each piece of equipment has its own dedicated computer with us because there's so many things that go on with so many different students. It's just going to be harder to keep track and harder to operate when we've got one computer that can operate 7 or 8 different machines. It's just not set up that way the appropriate, what we like at least. Okay. A couple of other tabs that you'll see over here: post-run, administration, and manual. These we don't really go into. Post-run maybe, and this is, of course, after the fact, and we'll talk a little bit more about that. But the administration and the manual, definitely not. We just don't see a lot of that at all. Next, once I double-click the GC 2014 icon, we got to the main computer screen, and this is the top corner of that main computer screen, or that home page, and it says GC not ready, but the AOC is ready. So the AOC is the auto sampler. That just literally means the power's on. I mean, there's nothing that the auto sampler really has to do too much other than just get some power, warm itself up, self-check itself, and we're ready to go. The GC, though, that has to have intake, it has to have flow, the detector's got to get ready, the flow rate has to stabilize. There's a lot of things that happen with the GC, and that's why that one is saying not ready quite yet, at least. All right, so in the next video, we'll pick up from here, what happens after the fact now, and that's how do we go through and pick out the instrumentation settings that we need for the machine. So that's what we'll talk about when we come back.